Hey, this is 5.3. We're going to look at adding, subtracting, and then multiplying polynomials. Adding and subtracting, multiplying polynomials, this is a pretty basic lesson. We're just going to go through some examples here to refresh your memory. When we add and subtract, remember, we're just combining like terms, and there's two ways that we can do this. The first way is to do them vertically, as shown here in example A. So you've got 3x cubed, and then right underneath it is 1x cubed. And we want to kind of think of the powers as places, like the ones, the two, the tens, and so on. And so we line those up on purpose. We've left a blank right here because there is no x term in my second polynomial. And now we're just going to add them. So I've got 3x plus 1x is going to give me 4x cubed. Now remember, we are dealing with exponents here. We've been changing exponents. When you add exponents, you do not, or when you add terms, I should say, the exponents don't change. A -2 and a -5 make -7x squared. There is no 4x or nothing to add to that 4x, so we just leave this as 4x, and then of course, -6 plus 3 is going to be -3. So that's nice, and this one was already set up for us. Just remember to, when you do set it up, line up the correct terms. You can also just kind of add them in a line like this, and I like to almost use just like a matching system. I don't have anything else over my second term with a cube in it, so it's going to be 2y cubed. And then I'm going to do like a squiggly line under 7y squared, and then it's -4y squared, so that's a positive 3y squared. And then how about x's underneath -6y, x's underneath 3y, so -6 and 3 makes -3y. And then, I don't have -9 underlined. Maybe I do circles here, and then it's just -9. So you just don't want to miss any terms. That's one of the biggest things, the most important thing here. Subtracting. We can do the subtraction the same way, subtract down. The key here is remembering that you have to subtract. So it's easy to see that it's going to be 7 minus 6, so that's just going to be an x cubed. What gets a little bit harder is then we kind of forget this negative, and then it's -6 plus 3, and we want to write this as -3x. I think that's just a typo there. That's actually supposed to be a square. -3x squared, when in reality, this is a negative, and that's a positive, and that's a negative. So I don't really like the vertical method when you're subtracting. It's just not a realistic method. Instead, I like to look at it horizontally, and I distribute the negative. So here we're adding, and I'm just going to rewrite 8x squared minus 5x plus 11 minus 12x squared plus 9x, and then plus 3. And now it turns into, just like the previous example, we're essentially adding, and we're just going to combine like terms. So I got 8x squared and a -12x squared to make a -4x squared. We've got a -5x and a positive 9x makes a positive 4x. And then a positive 11 and a positive 3 makes positive 14. So addition, subtraction, nothing too difficult there. What we'll slow down a little bit when we get to multiplication. And multiplication, we've done the FOIL, F-O-I-L. We know this method, and it works well, but it only works for binomials. It only works when you have A plus B and then like C plus D. It's first, outside, inside, last. You can't do first, outside, inside, last when you've got a trinomial like this, where you've got 1, 2, 3 terms. It just doesn't work. There isn't an outside, inside. There's too many terms, and so there's two ways you can approach this. You can think of it as just huge, like massive distributive property, and that's, I think, the easiest way. So just think of it as, I need to distribute this x to everything over there. So it becomes x cubed. X times 2x is 2x squared. X times -5 is -5x. And then we do the same thing with the -3. I need to distribute this -3 to everything. And as I write it, I'm actually going to kind of slide it over 1. So it's going to be -3 times x squared. That's going to be -3x squared. You can see right away why I did that. Now my x squareds are lined up. Negative 3 times 2x is going to be a negative 6x. And negative 3 times negative 5 is a positive 15. Now I can add down. And my simplified answer now is x cubed. This is going to be a negative x squared. This will be a negative 11x. And this will be a positive 15. So that's one method. I call it kind of the giant distributive method. The other method that I know you're familiar with is called the box method, or if you want to be fancy, the lattice method. You put one multiplier down one side and you make a box, and then you put one multiplier down the other side, and you're just essentially multiplying each individual term. And this is just an organized distributive method. It really works well. It keeps things in a nice, neat columns and rows, and a lot of times the diagonals will match up and become like terms. So x cubed, 2x squared, and a negative 5x. And you'll recognize those right from right here. I mean, these terms are exactly the same right there. You know, it's just organized distributive. It's not a different way. It's just how you're going to organize it. And then the same thing happens down below. We're going to have a negative 3x squared, a negative 6x, and finally a positive 15. And the nice thing about doing it this way is that you will, instead of having to shift it over like we did, your diagonals become like terms, as long as it's written in standard form and no terms are missing. So I'll kind of let you decide how you want to do that. It's, you know, either method is fine. When it comes to 3, unfortunately, we can't use the box method right away. We have to first use another shortcut, and then we can get to the box, or you can use this kind of expanded distributive property. But, you know, use whatever shortcuts you can. I think that we FOIL this first, so it becomes x squared, and then outside would be 7x, and then inside negative 3x. So you have a 4x total, and then last would be negative 3 and positive 7 makes negative 21. So that's what happens when you multiply those first two terms, and then you're left with x plus 1, and you can multiply those. And then to take it from there, your box method or your kind of massive distributive, you can do it that way if you want as well. I'll do the distributive property here again. Distribute the x to all of those things, and you'd be left with an x cubed plus a 4x squared minus a 21x, and then distributing the 1, you know, just kind of multiplies by 1. It's going to be exactly the same as you see. And now you're going to add down, and the nice thing is we've shifted that last one over one, so it all lines up nicely. 4x plus 1 is 5x squared. That's a negative 21, and a 4 makes negative 17x minus 21. So that is addition, subtraction, and multiplication.